Yes, good morning students, welcome back. Today we'll be revising coordinate geometry and after that we'll start with trigonometry. Yesterday we had finished most of the part of coordinate geometry. So let's recapitulate a bit. Distance formulas. See, you have to by heart all these formulas. You have to go through all these formulas because this chapter is based on formulas. Your distance formula is given by under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Section formula mx2 plus nx1 upon m plus n for x coordinate and for y coordinate my2 plus ny1 upon m plus n. Midpoint formula for x coordinate x1 plus x2 upon 2 and for y coordinate y1 plus y2 upon 2. Then centroid formula for x coordinate x1 plus x2 plus x3 upon 3 and for y coordinate y1 plus y2 plus y3 upon 3. So these four formulas, okay, you have to by heart, and once you get through all this, okay, you will get good marks in this chapter. Understand, this chapter is completely based on this formula, so revise these formulas properly. So let's move ahead. We'll solve some MCQ questions. Now see, the first question is the distance of point 2, 3 from the x-axis is, it's option A2, option B3, option C1 and option D5. This we'll solve it afterwards. You have to just go through these questions. Okay, you're going to do this as assignment questions. The next question is the distance between the point P 1, 4 and Q 4, 0 is. The options are 4, 5, 6, 3, root 3. Third question. If the distance between the points x, minus 1 and 3, 2 is 5, then the value of x is minus 7 or minus 1, minus 7 or 1, 7 or 1, 7 or minus 1. The two vertices of the triangle are 3, minus 5 and minus 7, 4. If its centroid is 2, minus 1, then the third vertex is option A, 10, 2, B, minus 10, 2, C, 10, minus 2, D, minus 10, minus 2. The coordinates of the centroid of the triangle whose vertices are 0, 6, 8, 12 and 8, 0 is 4, 6, 16, 6, 8, 6, 16 upon 3, 6. Just remove the screenshot of this. Remove the screenshot of this. We'll not waste our time in solving this question because we'll complete trigonometry. We'll start with trigonometry. Then everybody will have removed the screenshot. So we'll just move ahead. After going through all this, what you have understood, ask these questions to yourself. I can understand and apply the distance formula. Yes or no? I can understand and apply the section formula. Yes or no? I can understand and apply the midpoint formula. Yes or no? I can understand and apply the centroid formula. Ask these questions to yourself. Whenever the answer is no, just go back, revise that formula and solve the questions based on that. Is this clear to all the students? So we'll move ahead now. Here are some assignment questions for you. if a point A 0, 2 is equidistant from the points B 3, B and C B, 5, then find value of P. If two vertices of an equilateral triangle are 3, 0 and 6, 0, find the third vertex. Find the midpoint of the segment EP if A is 4, 12 and B is 8, 10. Find the ratio in which the y-axis divides the line segment joining the points -2, -4 and 8, 10. Also find the coordinates of the point of division. If point P divides the segment AB with A -7, 4 and B -6, -5 in the ratio 7:2, find the coordinates of P. You can remove the screenshot of this. These questions are there for your assignment. Everybody have removed the screenshot. Should we move ahead? Start with a revision of chapter trigonometry. Very important chapter, trigonometry. The application part in this chapter has been reduced from your syllabus for this year. Now, what is trigonometry? We'll just go through the definition of trigonometry. Trigonometry is derived from the Greek words trigon and metron. Trigon means three angles and metron means measure. So trigonometry is basically the measurement of three sides, three angles. Trigonometry is the branch of mathematics which deals with triangles, particularly the triangles in a plane where one angle of the triangle is 90 degrees. So that means trigonometry is basically applicable, or what we can say is we can use it for the triangles where one angle is 90 degrees. So that means it is used for the right angle triangles. Triangles on a sphere are also studied in spherical trigonometry. This is another branch which you will have this year for your syllabus. Trigonometry specifically deals with the relationships between the sides and the angles of the triangle, that is, on the trigonometric functions and with the calculations based on this function. We are going to study the trigonometric functions also as we move ahead. History of trigonometry. The origin of trigonometry can be traced out to the civilizations of the ancient Egypt, Mesopotamia and the Indus Valley more than 4,000 years ago. Some experts believe that trigonometry was originally invented to calculate sundials, a traditional exercise in the oldest books. The first recorded use of trigonometry came from the Hellenistic mathematician Pythagoras circa 150 before Christ, who compiled a trigonometric table using the sign for solving triangles. Many ancient mathematicians like Aryabhatta, Brahmagupta, Ibn Yunus, and Al-Kash made significant contributions in this field. Right triangle. Now basically, what is the right triangle? A triangle in which one angle is equal to 90 degrees is called a right triangle. Basically, is it audible now, ma'am? Angle is equal to 90 degrees is called a right triangle. Now here, if you look, understand this angle B is a right angle. The side opposite to the right angle is known as the hypotenuse. Now in this figure, AC is the hypotenuse. The other two sides are known as the legs. AB and BC are the legs of the triangle. Trigonometry deals with right triangle. So trigonometry basically deals with the right angle triangle. So The measurements of the right angle triangles. You know, by application of Pythagoras theorem, if the length of two sides are given, we can easily find the third side. So basically, when you're going to find the unknown lengths, okay, we are going to use this right angle triangle. So trigonometry deals with the right angle triangles. Now this is so Kato. This is really important. These are the short forms: SOHCAHTOE. Actually, this is the passport to the world of trigonometry. Understand? This is the passport to the world of trigonometry. But trigonometry actually revolves around these words. So, Kato. It sounds strange, but trigonometric ratios of acute angles of a right triangle. I'll explain what is the SOHCAHTO once we move ahead with the slides. The ratios of the sides of the triangle have special names. There are three basic ones we'll consider. Actually, all this revolves around these three basic ones: sine, cosine, and tangent. The sine of an acute angle, the ratio of the sine of an acute angle, how it is given, we'll study that. Let the lengths of the legs be A and B, and the length of the hypotenuse be AC. A is an acute angle. So if we're considering this right angle triangle, okay, angle A is an acute angle. The length of the sides are given to you as B, C, and A. Now, if you're going to consider A as the acute angle, I've shown an arrow. So, if you go with that arrow, side which is opposite to A is called as the opposite side. Next to angle A is called the adjacent side. And you know the side opposite to 90 degrees is called as the hypotenuse. So guessing which side is opposite side, which side is adjacent side is very important here. So with reference to angle A, the ratio of the length of the side opposite to angle A to the length of the hypotenuse is defined as sine A equals to the length angle A upon the length of the hypotenuse. Now, if you are going to consider small ABC as the length of the triangles, sine A is given as A upon C. Sine A is abbreviated as SIN. Hello. Yeah. Yeah. Yes, beta. Who is that? Speak up, beta. Speak up. Those are having the problems, come on. Unmute and ask. So sine A is abbreviated as sine A. This sine A equals to A upon C. So SOH, I told you, S for sine, O for opposite, and H for hypotenuse. Understand? So from that, you will get this as SOH. So, understand? S of sine, O of opposite, and H of hypotenuse. That is SOH. Understand like this. Now, once we go with all this, we'll come to know from the second and third slides. The cosine of an acute angle. Let the lengths of the legs be A and B, and the length of the hypotenuse be C. A is an acute angle. So consider this to be the right angle triangle, A to be the acute angle, length of the sides as small b, E, and C respectively. Hypotenuse, the side opposite to the 90 degrees, opposite side of A and adjacent side. Now with reference to angle A, the ratio of length of the side adjacent to angle A to the length of the hypotenuse is defined as cosine A, which is equals to the length of the side adjacent to angle A upon the length of the hypotenuse. So cosine A is given as the length of the side which is adjacent. Now in first case for sine it was opposite, for cosine it is adjacent. So that is equals to B upon C. If you consider the length ABC, so it's equals to B upon C. Cosine A is abbreviated to cos A. It is read as cos A. You don't read it as cosine A. In short, it is written as cos A. So this cos A equals to B upon C. We'll move to the tangent of an acute angle. Let the length of the legs be A and B and the length of the hypotenuse be C. A is an acute angle. So consider this to be the right angle triangle, A to be the acute angle, the length of the sides as ABC. Then you've got the adjacent side, opposite side, hypotenuse. Now with reference to angle A, the ratio of the length of the side opposite to angle A to the length of the side adjacent to angle A is defined as tangent A. So it is called as the tangent A, opposite upon adjacent. So that is equals to the length of the side opposite to angle A upon the length of the adjacent side. That is equals to A upon B. Tangent A is abbreviated tan A. This tan A equals to A upon B. Now check. So Kato. So T O A. Understand? This is the short form. So Kato. It is a short form to understand this ratio, sine ratio, cosine ratio, and tan ratio. Is this clear? Get to know SOHCAHTOA. What is basically the SOHCAHTOA? S for sine, check. O for opposite, H for hypotenuse. Understand? So sine theta equals to side opposite to angle theta upon the hypotenuse. So sine equals to opposite upon hypotenuse. Cosine, that is cos, adjacent upon hypotenuse. So cosine adjacent upon hypotenuse, ka. And toe, tangent, opposite, adjacent. So T for tangent, that is tan theta equals to opposite side upon the adjacent side. You know tan theta actually is the ratio of sine and cos. So tan theta equals to sine theta upon cos theta. Like that also you can remember. This is a clever technique. Most people used to remember these three basic trigonometric ratios. You can use this technique SOHCAHTOA to remember. See, SOHCAHTOA, it sounds strange. So what you can do is you can think that it is a Japanese name, a Chinese name. Understand, and you can remember that SOHCAHTOA. Is this clear to all the students? Is there any difficulty in this? Should we move ahead? We'll move ahead to the next part, understanding the trigonometric values of some special angles. The table of the values of the trigonometric ratio of angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These values are known as how to learn these values or how to get through these values. See, there is a simple technique. You see, the angles given are 0, 30, 45, 60, 90. These are called as the special angles, as these values of these angles are known to us. Now see, first of all, before going through the sine values, what you have to do is check your whole number. It starts with which number? Your whole numbers will begin with number 0. So what you will do is you'll write 0, 1, 2, 3, 4. Is this clear to all the students what we have done? We have taken this angle 0, 30, 45, 60, 90, and below that I have written all the whole numbers 0, 1, 2, 3, 4. Is this clear? Now, after that, which was the last number I got? I got it as 4. I got that as 4. So what I have done, whatever numbers I had written before, that is 0, 1, 2, 3, 4, I divided all those numbers with 4. Check. I've divided all those numbers with 4. Is this clear what I've done? I've written the whole numbers. After the whole numbers, my last number was 4. With that number, I'm going to divide all the numbers. I'm going to divide all the numbers. Is this clear to all the students? Now, after that, once you simplify, so 0 upon 4, answer is 0, 1 upon 4 would be written as 1 upon 4, 2 upon 4 will be reduced to 1 upon 2, 3 upon 4 will come as it is, 3 upon 4, and 4 upon 4 would be equal to 1. Is this clear? After this check, what I've done, I've written 0 to 4, divided with 4, and after that what I'm going to do is, I'm going to remove the square root. I'm going to remove the square root. So after removing the square root, what I'll get? I'm going to get the sine value. The sine value. Is this clear? After removing the root of 0 is 0, root of 1 upon 4, 1 upon 2, the root of 1 upon 2 is 1 upon root 2, root 3 upon 4 is root 3 upon 2, and last is root 1 equals to 1. I've simplified all this. Check. Root of 4 is 2. Understand? Root of 1 is 1, and this 2 would be written as root 2. Again, root 3, you cannot remove the square root. So you remove square root of 4. Square root of 4 is 2. Understand? So you've got all these values. So after simplification, whatever values you get is your sine values. Is this clear? Now, once you get this sine value, check all the table you're going to get it very easily. For cosine values, that is for cos values, what you have to do is, for cos values, you have to start writing those values in the opposite direction of sine. Check. Which is the last number here? 1. So that would be first number for cos. Second last number will be second number. Your middle number would be as it is. The second number would be the second last number, and first number would be the last number. Check. I've written that in the opposite direction. The value I've started writing it on the last number. Is this clear to all the students? Check. Sine is easy, cos is easy. Now, after that, tan value. After that, tan value. Now, for tan, what you have to do is, you have to take sine upon cos. You have to take the values of sine upon cos. So, better what you do is, you only take the numerators of sine as well as cos. Numerator of sine here is 0. Numerator of cos is 1. So here you write 0 upon 1. So what is 0 upon 1? The answer is 0. Again here check. What is the numerator here? 1. What is the numerator here? Root 3. So answer is 1 upon root 3. Is this clear? After that check. Here it is 1. Here it is 1. So what will get? 1 upon 1. Answer is 1. Next value, root 3 and 1. You get that as root 3 upon 1. So root 3 upon 1 is what? Root 3. Next is, check, here it is 1 and here it is 0. So 1 upon 0. What is the answer? Not defined. Check. Whenever there is denominator 0, you cannot find the answer. It is written as not defined. Is this clear to all the students? Is this clear to all the students? Any doubt? You need not by heart this table. Understand what I've done. Okay, if you go with mugging up the values, understand there is a possibility of making mistakes. So what you have to do is very simple technique. You have to write first all the angles. These are called as a special angles because these values are directly known to us. That is 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. After that, you'll write all the whole numbers in the given columns. Check 0, 1, 2, 3, 4. Whole numbers. You start with the whole numbers. After that, which is the last number here? 4. You divide all the previous numbers with 4. After that, you simplify this. After simplification, you get that as 0, 1 upon 4, 1 upon 2, 3 upon 4, and 1. After simplification, what you have to do is you have to remove the square root. You have to remove the square root. So square root of all this, square root of 0 is 0, square root of 1 upon 4, check. The square root of 1 is 1, and square root of 4 is 2. You'll get that as 1 upon 2. Again, a square root of 1 and root 2. Square root of 3 and 2, and square root of 1. After removing the square root, whatever values you are going to get, these values are of sign ratio. This is of sign ratio. That is for sine theta. Sine 0 is 0. Sine 30 is 1 upon 2. Sine 45 is 1 upon 2. Sine 60 root 3 upon 2, and sine 90 that's 1. Then you'll get cos. For cos, what you have to do is whatever values you have got it in the sine table, start it in the reverse order for cos. Start it in the reverse order for cos. That is the last number will become the first number. So sine 90 equals to cos 0. That is 1. Understand? Then sine 60 equals to cos 30. That is root 3 upon 2. Sine 45 equals to cos 45. That is 1 upon root 2. Then sine 60 equals to cos 60. That is 1 upon 2. And sine 90 equals to cos 90. That is 2. And after that, you have to take the ratio of sine and cos for value of tan. Now, after getting all these values of sine, cos, and tan, you can easily get values of cosec, then sec, and cot. Understand? Inverse of sine is cosec, inverse of cos is sec, and inverse of tan is cot. So easily you get through this value. Check how to remember what is the inverse of sine. Check here, sine it begins with S. So its inverse will begin with C, that is cosec. And here its inverse is C. That it begins with C. The inverse will begin with C. Is clear? So in that way you have to remember. So 1 upon 2, inverse will become 2 upon 1. It is clear to all these things. You need not by heart anything. Check. You have to just understand the technique how to find the values of those angles. The table of the values of the trigonometric ratios of angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. This is the complete table where all the values like sine, cos, tan. But I'll tell you that remember how to get value of sine. Once you get value of sine, all the values would be known to you very easily. Is clear? This is there in your textbook. So we'll move ahead. Now next is the trigonometric identity. Now these trigonometric identities are used to solve the problems regarding the proof. Understand? Use this to solve left hand side equals to right hand side to solve the values also. So please understand. The first identity is sine square theta plus cos square theta equals to 1. Next identity is 1 plus tan square theta equals to sec square theta. 1 plus cot square theta equals to cosec square theta. We'll go through the proof of these trigonometric identities. How are these derived? Trigonometric identities. Now, in figure, triangle ABC is a right angle triangle. Now, you know, trigonometry is basically the right angle triangle. So, take the values of the right angle triangle. So, assuming that triangle ABC is a right angle triangle and angle B equals to 90 degrees, side opposite to 90 degrees is called as the hypotenuse. If you're considering angle A as theta, so side opposite to angle E, that is BC, will become the opposite side. Understand? Show these arrows to make you understand which is the opposite side, which is the adjacent side. This makes it easy. So the remaining side which is there is your adjacent side. So by applying Pythagoras theorem, you get BC square plus AB square equals to AC square. Now dividing both sides of 1 by AC square, you get BC square upon AC square plus AB square upon AC square equals to AC square upon AC square. We've divided that. Now check. Here everywhere square is common. Everywhere the square is common. Here check 2, 2, 2, 2, 2, 2. So what you will do is you remove that square common. So once you remove that square common, the equation would be written as BC upon AC, the whole square, plus AB upon AC, the whole square. And here AC square upon AC square gets cancelled. Understand? So you'll get, now check, sine square theta. Now why sine square theta? I've written BC upon AC, the whole square. Now sine theta is given as opposite side upon the hypotenuse. Is this clear? Sine theta is given as opposite side upon the hypotenuse. Your opposite side is BC. The opposite side is what? BC. And hypotenuse is BC. So BC upon AC is sine square. Because here it is square. So sine square theta. And again for cos theta. For cos theta, it is the adjacent side upon the hypotenuse. And adjacent side is BA or AB. So AB upon AC. So AB upon AC, the whole square is written as cos square theta. This is your identity number 1. Is this clear to all the students? This is the derivation of that. Now dividing both the sides of equation 1 by sine square theta means the identity which we have got. The identity which we have got. So dividing that with sine square theta. So what will get? Sine square theta upon sine square theta plus cos square theta upon sine square theta equals to 1 upon sine square theta. Again, the square thing is common. So what you will get? Check sine square theta upon sine square theta gets cancelled. That is 1. Now cos theta upon sine theta is cot theta. So cos square theta upon sine square theta will be cot square theta. And inverse of sine is cosec. So you get that as 1 plus cot square theta equals to cosec square theta. This is your identity number 2. Now, instead of dividing that with sine square theta, if you divide that with cos square theta, what will you get? You get sine square theta upon cos square theta plus cos square theta upon cos square theta equals to 1 upon cos square theta. So sine theta upon cos theta is tan theta. So sine square theta upon cos square theta equals to tan square theta. So you get that as tan square theta plus 1 equals to sec square theta. This is your third identity. Is this clear to all the students? Now, trigonometry is used to solve real life problems. Now, it has got wide extensive use. So where it is used, measuring the height of the trees. What would you need to know in order to calculate the height of this tree? What trigonometric ratio would you use? Next is finding the height of the towers, tall buildings, skyscrapers, towers, and mountains. Now solve real problem. Now check to find the distance of island from the beach. Assume the line in the middle of the drawn triangle is perpendicular to the beach line. How far is the island? These all questions are answered with help of trigonometry. This is clear to all the students. There are many more examples. You can search on the internet. to get through its application. Now let's solve some questions based on this, this illustrative examples. Let's check. The question is, if sine theta equals to 7 upon 25, find the values of cos theta and tan theta. Now here there are two methods of solving this. First is using the identity, the trigonometric identity to solve, and other is using the trigonometric ratio. We solve it by both the methods. Now check if sine theta equals to 7 upon 25, you define values of cos theta and tan theta. So given is sine theta equals to 7 upon 25. Now you know the identity with respect to sine and cos. So you define value of cos. If sine is given, you can easily find value of cos using the trigonometric identity. That is sine square theta plus cos square theta equals to 1. Now, what you have to do is you have to just substitute the value. Check sine theta is 7 upon 25. So in case of sine square theta, you substitute 7 upon 25 to the whole square. Plus cos square theta equals to 1. Square of 7 is 49. So you get that as 49 upon 625 plus cos square theta equals to 1. Now what you will do is you want value of cos square theta. So what you will do is you keep cos square theta on the same side and you change position of 49 upon 625. So plus 49 upon 625 when it goes to the other side becomes minus. So that answer is written as cos square theta equals to 1 minus 49 upon 625. Here you cross multiply. What do you do? You cross multiply. Understand? So 625 into 1, there is 625 minus. Now your 1 does not have any denominator, so by default it is taken as 1. So 1 into 49 is minus 49. So 625 minus 49 upon 1 into 625, that is 625. So you get cos square theta as 576 upon 625. Now in order to get value of cos theta, you need to remove the square root. So once you remove the square root, you'll get value of cos theta as 24 upon 25. Understand? You can apply the trigonometric identity to get value of cos theta. Now once you get value of cos theta, your tan theta is sin theta upon cos theta. So what you will do is you substitute the values. You know value of sin theta, you know value of cos theta. So 7 upon 25 upon 24 upon 25. So division. So 7 upon 25 divided by 24 upon 25. Now you know once you replace this division sign with multiplication. Once you replace this division sign with multiplication, you have to take the inverse of the number after the division sign. So inverse of 24 upon 25 is 25 upon 24. So 25 would get cancelled. You will be left out with 7 upon 24. So tan theta equals to 7 upon 24. So therefore, value of cos theta is 24 upon 25 and tan theta is 7 upon 24. Is this clear to all the students? This is the first method using the trigonometric identity. Now we'll solve it by the other method, the alternate method. It is using the trigonometric ratio. Now consider this to be triangle ABC where B is 90 degrees and angle C is theta. So when sin theta is given to you, that means the value of the opposite side and the hypotenuse is given to you. As it is in the ratio, you take the common multiple as k here. You are taking the common multiple as k. So opposite side becomes 7k and the hypotenuse becomes 25k. This is clear to all the students as it is in the ratio or it is in the fractional form 7 upon 25. So whenever you get this terms in the ratio form, you take the common multiple as a variable, that is k or x, which is a constant. This is clear. So now in triangle ABC, angle ABC is 90 degrees and angle ECB is theta. So sin theta equals to AB upon BC. So therefore, AB upon AC is 7 upon 25. So assume AB as 7K and AC as 25. Now, with respect to this, in triangle ABC, angle B is 90 degrees. You've got angle B as 90 degrees. So therefore, AB square plus BC square equals to AC square. This is by Pythagoras theorem. So with respect to this, what we get? 7K the whole square plus BC square equals to 25K the whole square. So to solve this, 7K the whole square is 49K square, and you shift it to the other side. So when it goes to the other side, it becomes minus 49. So you get BC square equals to 625 minus 49K square. 625 minus 49 is 576. So BC square is 576K square. So BC equals to 24K. Now cos theta equals to BC upon BC. Now you know that value of cos theta is BC upon BC. That means the adjacent side upon the hypotenuse, the adjacent side upon the hypotenuse. So that is 24K upon 25K. K which is common now for both will be cancelled out. So cos theta is 24 upon 25. And similarly for tan theta is for opposite side upon the adjacent side. So just substitute this value 7K and 24. K up and down get cancelled. It will be left out with tan theta equals to 7 upon 24. So therefore, cos theta is 24 upon 25 and tan theta is 7 upon 24. You can solve this using any of the method which you find easy. So I'm repeating this. You can do this by any method, the method which you find easy to solve. Is this clear to all the students? The next question. If tan theta equals to 1, then find value of sin theta plus cos theta upon sec theta plus cosec theta. Now tan theta equals to 1. Now if you look in the trigonometric table, for which value of particular angle, okay, it is equal to 1. So if you go in the tan table, value of 45 would be equal to 1. Yes, ma'am, you have raised your hands, ma'am. Ma'am? So tan 45 equals to 1. So tan theta equals to tan 45. So with respect to this, you get value of theta as 45. Now, sin theta equals to sin 45. Now you've got value of theta as 45. So sin 45. So you go in the trigonometric table, you get value of sin 45 as 1 upon root 2. Value of cos 45 again as 1 upon root 2. Sec 45 root 2. And cosec theta, that is cosec 45 equals to root 2. Now you combine all this and you substitute all the values. You get 1 upon root 2. Yes, beta, what happened? My voice is not audible?
Yes, sir.
Just a minute.
Your voice is breaking.
Now, is my voice clear? Ma'am, is my voice clear?
Yes, sir.
Yes, sir, it's clear now.
Yeah. So now, once you substitute all these values, you get that as 1 upon root 2 plus 1 upon root 2 upon root 2 plus root 2. So that is written as 2 upon root 2 divided by 2 root 2. So what you will get 2 upon root 2 into 1 upon 2 root 2. So that is taken as 1 upon 2. Is this clear to all the students? Two participants have raised their hands. Any difficulty?
Those who have raised their hands, first rename yourself. We are not able to understand which school, what is your name. We are not able to understand that. First rename yourself and then raise your hand. Vishal, you are raising your hand.
Yes, Vishal, you have raised your hands, beta. Yes, Vishal.
Vishal, Alok.
Yes, sir.
Yeah, beta, what is your problem,
Yes.
beta?
Sir, I not understand this sum.
Okay, I'll explain this again, beta. I'll explain this again. Alok. Alok.
Alok, ask your doubt. Who is this one who has raised his hand? He has just kept some two emotions. I'll remove that such children, those who are kept only such emotions. Kindly rename your name with your name and school name. It's been told from the starting of the lectures. Yes, those who have raised the hand, they can ask their doubts because it's already time up.
Yes, Anchal, Aman, you can unmute and ask.
Those who have
Aman.
raised their hands, unmute yourself and ask immediately. It's time up for this lecture. We have to start with the next lecture.
सर ये वाला सम एक और बार बताओ ना सर.
Okay,
Madam.
Anchal, ask
Yes,
beta.
miss.
Miss, sir, this is now sin quality to sin 5 degree में.
I didn't get you, beta. What did you say?
Sir, नीचे वाला.
Wait, I'll explain that again so that you'll understand. I'll explain it
Yes, sir, yes.
to everyone. Yes. See
Sir,
now, what is?
Sir,
Huh.
sir, आपको two equal to क्या है? 2 upon divide 2 क्या है?
Yeah, na?
हाँ, yes.
See, it is 2 root
2
2
से 2.
upon 2 root 2. So
Yes.
this upon sign denotes
Yes.
division. Understand? So because of that, it is shown division
Yes.
over here.
हाँ.
Is this clear?
सर उधर मल्टीप्लाई आना चाहिए.
Yes.
इधर मल्टीप्लाई करने के बाद देखो क्या होता है, डिवीजन वाले नंबर के बाद मतलब डिवीजन साइन के बाद का नंबर उसका रेसिप्रोकल आता है. So that is 1 upon 2 root 2. Understand this?
सर पहले रेसिप्रोकल करते कि डायरेक्ट.
See, डिवीजन के बाद अगर देखो डिवीजन साइन आता है बीच में तो आप पहले उसको मल्टीप्लाई करते हो और डिवीजन वाले नंबर मतलब डिवीजन के बाद जो नंबर आता है उसका रेसिप्रोकल लेते हैं.
और अदर्स.
हाँ, सो
Others.
ये 2 और 2 कट हो गया.
अदर्स तो लेक्चर में नहीं है क्या?
Yes.
Yes, who is this?
No other questions to be asked. Now root 2 into root 2. Root 2 into root 2 is 2. Understand? Anchal, did you get this? और यहाँ पे tan theta equals to 1. So see, when you will get tan theta equals to 1, so to check these values in the trigonometric table. I told you how to get the values in the trigonometric table. So tan 45 would resemble to tan theta, that is 1. Understand? Your tan 45 is 1. So tan theta equals to tan 45. So tan is same. So it will get cancelled. You get theta equals to 45. Now once you get value of theta 45, you just substitute here sin 45 cos 45. So check, you will get that as 1 upon root 2 plus 1 upon root 2. And below sec theta plus cosec theta, that is root 2 plus root 2. So to just substitute that value, nothing else. Is this clear?
Thank you, sir.
Yeah, thank you.